Earlier this week, we did section 17.1, which used the basics of sine, cosine, and tangent. It was almost entirely review from last year. A little bit of new stuff, but almost entirely review from last year. 17.2 is something you probably did not see last year. Because we're on distance learning, online learning this year, it was decided to just make this an assignment, an extra credit assignment. Some teachers aren't assigning it at all, but I'm making it an extra credit assignment. The first part is pretty easy. I hope you already watched the video notes Mrs. Franklin did. I didn't make my own notes this time because I thought instead I'd work out all these odd problems. You're not going to do the odds. You're going to do the evens. Since it's extra credit, you're only doing evens. None of the answers are given. These are just good examples for you to see what you're doing without me actually working out any of the problems for you. Here we are finding the area of the triangle. And the formula for the area of a triangle is normally area equals 1/2 times the base times the height. That only works when you have a right angle so you can find the actual height. These are triangles where we don't have the height. We could figure out the height. It might take some more work, but we could figure out the height. In this one, the height would have to be out here somewhere. That's a lot more work than we want to do. So I'm going to get rid of those marks and talk about a different way to do this. The formula we're doing instead, I'm going to write it in words instead of letters. Area equals 1/2. And we usually do the base times the height, but I'm just going to say the side times the side times the measure of an angle. That angle has to be the angle that connects the two sides we know. Okay. So in this triangle, I'm going to write the area equals 1/2 times the side times the side times the sine of the angle. And it's never cosine, it's never tangent, it's only sine. This is always sine. Now, in these examples, they've given you a side of 4, a side of 3, and the angle where those two meet is 120. Even if they gave you this angle, this side over here, we don't care. We want two sides and the angle where they meet. In this case, two sides and the angle where they meet. Area equals 1/2 times the 7 times the 7 times the sine of 130 degrees. Don't really need those parentheses on the end, do I? Now all I have left to do is put that in the calculator. My calculator tells me that this one is 5.196. It goes forever. We're looking for answers to the nearest tenth, and tenth means one place past the decimal. So my area is 5. Here's a 1, but my deciding factor is the digit after it. If the digit after that, the digit that's 2 places over, is 5 or higher, we have to push up. 5.2, and that's area, so it should be square something. They didn't tell me what. I could write square units. In my opinion, if they didn't bother to tell you what's on there, it's okay to just give the number part. But if this had been 3 feet, I would have had to say 5.2 square feet. I could have written that as square feet, or I could have written that as feet squared. They mean the same thing. But in this case, they didn't tell us. we don't have to write it. The second example here, when I put that into my calculator, I end up with 18.768 forever. 18, I need one place past the decimal, but again, the digit that's in the hundredths place, 2 spaces over, is 5 or larger than 5. I'm going to make this up to 18.8. And again, that's 18.8 square something. If they didn't tell you what kind of something, it's okay with me if you just write the number. But some teachers are going to be picky and ask you for square units. There are actually 3 odd problems that deal with this, but this is an easy enough thing that I don't think I need to do the third one. So I'm skipped number 3. And let's go on to solve the triangle problems. These are not right triangles. That means I cannot use Pythagorean theorem. I cannot use basic sine, cosine, and tangent. I'm going to use law of sines. It says find all the unknown measurements using law of sines. We will have to use law of sines somewhere in here, maybe for 2 of them, but the angles often don't need law of sines. If they give you 2 angles out of 3 in a triangle, it doesn't matter if it's a right triangle or anything else. We can just say 180 minus the 80 we know, minus the 50 we know. I'd say 180 minus 80 is 100, minus 50 is 50. So I have right here in this corner 50 degrees. If you watch Mrs. Franken's video, she puts that part into her calculator and never puts it on paper. In my class, you need to put it on paper. When I get it home after you've submitted it, I can't tell what you put in your calculator. She's showing you on her video what she's put in the calculator, but I can't tell what you put in the calculator. So you need to show me that even if it seems very simple to you. Now, when I'm trying to solve the triangle, I have to find 3 angles and I have to find 3 sides. Some of these numbers are labeled, some of these sides are labeled with letters, and some of them are labeled with numbers. But one thing I know from 17.1, which was a required assignment, not an extra credit assignment, is if you have side A, you need angle A opposite from that. If you have side lowercase b, you need a capital B across from that. When we did right triangles, we usually called C the right angle. And since I don't have any right angles here, I'm not going to choose to call anything C. Sometimes I don't have a choice because they already put the letters on for me, but I'm just going to call this capital X and this one over here that we already know lowercase x. So I'm coming down to my answer space here and saying, I now know measure of angle A, 50 degrees, measure of angle X, 50 degrees, measure of angle B, 80 degrees. Please don't forget the degree symbol. Side A, don't know yet. Side B, don't know yet. Side X is 10. They didn't tell me inches, feet, meters, miles. If they tell you, you have to put it on here. And now I have to figure out how I'm going to do the other sides. No Pythagorean theorem, no basic sine, cosine, tangent, because there's no right angle in here. Unless I wanted to draw a line and put a right angle in there, it's not going to help me any. So I have to use the new rule that you just learned today, if you watched your notes today, which is the sine of A over lowercase a, sine of B over lowercase b, sine of, I said C in the notes, since I'm using x, sine of x over lowercase x. You really can't work with all 3 fractions. You just work with whichever part you need to work with. First thing I always look for is, I know I'm only going to be able to use law of sines if somewhere I can find an angle and a side that are opposite from each other and both have numbers. I don't know both capital A and lowercase a because I don't know the angle. I don't know both capital B and lowercase b because I don't know the side. And I don't know the side on either one of those. I do actually know the angle because I worked it out. Side x, lowercase x, were also given to me in the first place. So I'm going to set up to find those two sides. And I'm going to be using sine x over x for both cases. Sine capital X over lowercase x. Which means I'm going to use the sine of 50 over 10. Over here, though, I need something else. If I wanted to find, let's find A first, the sine of capital A, which is 50 degrees, over lowercase a that I don't know. This wouldn't have worked very well if I didn't figure out that angle first. Okay, changed my 50 to a letter A. This step, optional. This step, absolutely required. Once you have the two angles set up, the two fractions set up equal to each other to make a proportion, I need to get the letter by itself. When the letter's on the bottom, I always start with cross multiply. So I have A times sine 50. Just make that. A times sine 50, 10 times sine 50. This one's unusual. I got sine 50 on both sides. That's okay. Now I need to get that sine 50 by itself. So let's need to get rid of the sine 50 so I can get the A by itself. Let's divide sine 50 on both sides. Divide sine 50 on both sides. This is an unusual situation because all I have is A equals 10. Do you know why that happened that way? Why that worked out so nicely? Last year, you learned a theorem that said if two angles of a triangle are equal, then the sides opposite from those angles will also be equal. I've been thinking about that theorem. I wouldn't have had to do law of sines at all to get that problem. You're used to seeing me in class. You know I have all these little hand gestures, and I'm suddenly realizing I'm talking with my hands, and you can't even see what I'm talking about with my hands. Oh well. Okay, so the fact that two angles match should have actually told us the two sides matched. I still need to figure out the third side. So let's go back over here and say I'm going to work with finding the other missing part. What's the other part I haven't worked with? I already know that A is 10 and X is 10. I need to work on B. So I need a lowercase b right here, and I need a capital B up here. That means that this side's going to turn into the sine of the B angle I know over the B side I don't know, and that is going to be equal to the sine of the X angle I know over the X side that I know. Both of these are using sine 50 over 10 because that was the only situation where I had a number on both an angle and a side opposite from each other. Okay, let's solve it. We're going to cross multiply sine 50 over 10. I was rewriting the same problem. This is the B times the sine 50 equals the 10 times the sine 80. Notice I didn't actually do 10 times sine 80 because then I'd have to deal with whether or not to round it off or keep every digit in my calculator, I just say I need to get the b by itself. Divide sine 50. Divide sine 50. And I get b equals 10 times sine 80 divided by sine 50. Now, depending on your calculator, you might need to throw in parentheses here, parentheses here. When I type that into my calculator, it actually looks like this. 10 times sine 80 divide sine 50. And if I don't have parentheses right here to end my 80, it's going to think divide by sine 50 is inside the original sign. So watch your calculator. Notice if you're not getting the right answer here, maybe you need to go back and recheck how the calculator is interpreting your expression. And my calculator tells me that is 12.855. I'm rounding to the nearest tenth. B equals 12.8 or 12.9. 5 is that number that just barely pushes it up. 12.9. Let me come back to my answer space over here, and I just figured out that B is 12.9. Okay, I found every part of that triangle. Let's move on and look at another problem. Let's do number 11. Number 11, let me first analyze what I know. They told me lowercase c, so I have to say opposite from lowercase c, capital C. I don't really like capital C being something that's not a right angle, but I don't have a choice when they already gave me C for the lowercase side. I have to call the angle capital C. And it looks like I know angle C, 15 degrees. They gave me lowercase b, and opposite from lowercase b, it almost looks like the 14's opposite from there, but I need an angle opposite from there. I need the only angle where the vertex doesn't touch this. That touches the b side. That touches the b side. I need this over here to be my capital B. Don't know capital B yet. And then I have one more angle to deal with and one more side to deal with. I'm going to just go ahead and use A, say angle A 130 degrees. And opposite from that has to be lowercase a 14. Okay. Do I know two angles? Yes, I do. If I know two angles, I'm going to figure out the third angle by saying 180 minus 130 minus 15. 180 minus 130 is 50. Minus 15 should be 35 degrees. That is this angle right here. 35 degrees. Angle B, 35 degrees. I know I'm going to have to use law of sines, so I am making a setup for two problems here. Sine of something over the side opposite. Up here I'll do the other one. Sine of some angle over the side opposite. Sine of some angle over the side opposite. To know that it's possible to use law of sines, the first thing I always look for is, can I find an angle and a side where I have numbers on both of them? And I can see A. this. Angle A, capital A is angle A, and lowercase a is the side. So let's just say capital A. I'm not going to write the letters this time, I'll just write the numbers. 130, lowercase a, 14. Over here, capital A, 130, lowercase a, 14. Both equations are going to start with that fraction, because that's the only situation where I know actual numbers on the angle and the side that's opposite from that angle. The two sides I need to find are side B and side C. In order to find side B, I have to know angle B. Do I know angle B? Yes, I know angle B. I worked it right there. 35. Do I know angle C? Yes, they told me angle C. Now I'm going to do cross multiply and divide on both of those setups. So on this first one, cross multiply, I have B sine 130. Parentheses aren't mathematically required on paper, but they might be required in your calculator. Equals 14 times sine 35. I need that B by itself. I can't just divide out 130 because 130 is stuck with the word sine. So I'm dividing by sine 130 to make that go away. Dividing by sine 130 over here. Now, some people would be tempted to cross out the word sine and just work with the rest of that. You can't do that. This 35 is all tied up inside its sine. This 130 is all tied up inside its sine. I'm actually doing B equals, in my calculator I will do 14 times sine 35, and then we'll divide by sine 130. And again, watch. If you don't get the same answer in your calculator that I'm getting, you know you need those parentheses. You better go back and put them in. Or maybe you put in too many parentheses. Go back and check your parentheses if it's not working out. I'm sorry, I'm not sitting in class. I can't walk over to you and say, oh, I see what you did. You'll have to play with your calculator and look at it carefully and see where you went wrong. I love being able to just walk out to a person and say, I see what you did. Because sometimes it's so hard to see your own mistakes and other people can spot them easily. Let me check what my calculator gives me for this. My calculator tells me B equals 10.48, and I know that I'm rounding to the nearest tenth. 10.4, that 8's going to push it up and call it 10.5, and that is side B. And then we'll come over here. Pause. Cross multiply and divide by yourself. See if you can get it right. I'll pause, fill it in, and I'll come back to you. So, is that what you got? This step, totally optional. It's just for me to show you what I'm putting into my calculator. You may have a calculator where you can make an actual fraction out of this. That's nice because the parentheses don't cause as much of an issue that way. Didn't round it off yet. 4.7. 3 is not big enough to push it over, so it's just 4.7. We'll come over here and write 4.7. I think we need to see another one of that type. Okay, this is number 21. This is a word problem, but it works just the same way. As the ship approaches the dock, it forms a 70-degree angle between the dock and the lighthouse. At the lighthouse, an 80-degree angle is formed between the dock and the ship. How far is the ship from the dock? Well, they put the numbers on for us already. We have 70-degree angle between the dock and the lighthouse. Where the ship is, between the dock and the lighthouse, 70 degrees. Oops, almost lost my whole picture. And we know that an 80-degree angle is at the lighthouse, forming an 80-degree angle between the dock and the ship. Again, already on the picture. How far is the ship from the dock? So I'm really looking for this side right here. I think it's going to be easier if I throw some letters on there. Lighthouse, they told us, is at sea. That makes the side we're looking for is a lowercase c. Everything else I need probably has numbers already. So, in order to be able to use this law of sines thing, I have to know an angle and a side that are opposite from each other. I'm going to say 80 and C. I don't know that, both of those. I'm going to say, I don't know, this or this, so they're really not helping me. But I do know those two. That's going to make my first fraction. Sine of the angle I know divided by the side opposite from that. And what am I trying to find out? Trying to find out lowercase c. Lowercase c would have to be on the bottom. I have all the sides on the bottom. And the sine of the angle opposite that is 80. There's my setup. I don't actually have to solve the whole triangle this time. So let's just do a little cross multiplying. We have c sine 70 equals 5 sine 80. We want c by itself, so we divide out sine 70. Again, don't try and just get rid of the word sine. The word sine is all tied up with an angle. You can't have sine without an angle, because sine without an angle, that's just sin, and that's just wrong. Silly, but maybe it'll help you remember that. Okay, I'm trying to get the c by itself. So now I have c equals, and I have to grab my calculator, and I have to do 5 times sine 80 divided by sine 70. In my calculator, the parentheses matter, so I'm going to throw those in there. That gives me 5.24, I don't know after that. 5.2, because 4 is not big enough to push it over. Have to be 5 or larger to put it over. This one's a word problem, so I need to go back and figure out what are these sides measured in. Looks like I'm dealing with miles. This is a distance, not an area, so it's just 5.2 miles. There we go. Okay, here's a problem I skipped a few minutes ago. I'm going to fill in a lot of stuff and then get back to you. Okay, I labeled my angles A, B, and X because I'm not using C unless I have to. I labeled them by looking at opposite from a capital letter would be the same letter lowercase. And then I took the two angles I knew and I came up here and I did 180 minus 150 minus 20 and got 10 degrees for my last angle. Then I need to try to set up a law of sines proportions in order to find my two missing sides. That will be sine of something, each of them with a side opposite underneath. Sine of something, sine of something. The two that I know, the only side I know is 18. So I better be able to find 18 and x. They didn't give me the x, but I did figure out for myself that x is 10. So I'm going to be able to use 10-degree angle over 18 side. 10-degree angle over 18 side. I have to find my A side, and that means I'll need my A angle. I have to find my B side, and that means I'll need my B angle. This video is running very long, so I'm going to pause, work those out, and then you can check and see if you got the same answer I got. Did you get the same answers I got? I wanted to stop and talk to you for a minute about something else that you should know from last year. Something that will help you to know whether you have these at least reasonable. Last year we learned that in any triangle, the biggest side should be opposite from the biggest angle. So I'm saying my biggest angle is 150. My biggest side is 51.8. Good. A opposite from A, the largest. We also know the smallest angle should be opposite from the smallest side. My smallest angle is 10. My smallest side is 18. Smallest side across from smallest angle. And of course, ultimately you can see that middle size angle, middle size side. Let me look at one that we did before. Largest angle 130, largest side 14, both A. Now the largest is not always A, just happened here. Smallest side 4.7, smallest angle 15. Smallest side across from smallest angle. One more. The remaining medium-sized side, medium-sized angle. You don't have to check that every time, but it helps. It helps you to catch your mistakes on things like this. You can do that. I didn't think to mention it before, but you can do that on 17.1 also. When you're doing solve the triangle, make sure it turns out that way. Biggest side across from biggest angle. Right angle, 90-degree angle across from the hypotenuse, which is always the biggest. But also check that the smallest angle is opposite the smallest side. The medium-sized angle is opposite from the medium-sized side. There's another one. Biggest angle, 80. Biggest side, 12.9. Smallest, oh hey, we have 50 with 10, and we have another 50 with 10. That's because that triangle happened to be isosceles. Remember that I said if you happen to notice it's isosceles, and I'm pretty sure that one of the even ones is that way. You won't have to do a lot of signs to work out both sides. So if you recognize two equal angles, the sides opposite those have to be equal. That'll save you a little bit of time on that one problem out of the whole thing. Okay, I hope this has helped. Since this is an extra credit assignment, I didn't provide you with any answers to the problems you're working out yourself. There are 8 problems that I assigned on both Google Classroom and School Loop. I wrote this as an assignment out of 1, which means that if you get 1 out of 1, you got 100% assignment. If you get 8 out of 1, you've got a lot of extra credit. If you choose to skip this assignment, you're allowed. They're knowing that they're probably going to have to reteach it next year. You're allowed to skip it if you want to. But for some of you at this point, if we have no more big tests to deal with this year, which it sounds like it's possible, that may be possibly not even going back to school except for maybe the last week of school for finals. These little extra credit things, those are your only chance to bring up your grade. So I think it's worth doing this. If your grade's borderline, try things out. Okay, you can call me and ask me questions on this, but I will only answer brief questions. I won't work out actual problems from the assignment for you since this one's an extra credit. But I will be willing to work out some more problems similar to this There are a couple of the odds that I might have skipped. Still, you can call me or email me if you need help. This video got plenty long.